Let's do another polynomial division. So I have p of x, which is a cubic, and I want to divide into that this monomial, the straight line q of x. So I want to write p of x divided by q of x, and then I want to decompose the big polynomial into the smaller polynomial times some quotient, and then plus or minus some remainder. So let's work on the division, p of x divided by q of x. And by long division, we write q of x on the outside of the garage and p of x on the inside. So q of x is going to be 3x plus 2 dividing into 9x cubed minus 5x squared minus 12. Okay. So I'm going to go through this process a little bit faster than the last video. All right, 3x into 9x cubed gives me a 3x squared. I then run that backwards. I get a 9x cubed plus a 6x squared, which I wrap in parentheses and I subtract. I end up with a minus 11x squared minus a 12. I then can do this again. I need a minus 11 thirds and an x. I then run this backwards. I get a minus 11x squared minus a 22 thirds x, which I wrap in parentheses and subtract. I end up with plus 22 thirds x and a minus 12. I need to do this one more time. 3x going to 22 thirds x. I need a 22 over 9 and no x's anymore. All right, 22 over 9 times 3x gives me a 22 over 3x. And times 2 gives me a plus 44 over 9, which I wrap in parentheses and subtract. I have no x's now, and I do have a constant minus 12 and minus 44 over 9, which if I get a common denominator, gives me minus 108 minus 49 over 9. Gives us minus 157 over 9. Okay. So I have to stop. Right, because there's no way to go from a 3x into a constant. So we're done. And we can write p of x as q of x, which was the 3x plus 2 times the quotient, the result of that division, 3x squared minus 11 thirds x plus 22 ninths. But we weren't able to do that evenly. We had a remainder. The remainder was minus 157 over 9. So don't trust me here. Pause the video, work through this algebra, and show that you actually do end up with p of x.